This late one, come in.
Perfect. Thank you. All right, my friends. Here we go. You guys ready?
Yeah.
We're in our book. We're looking at what we did yesterday. Yesterday we were translating. What did that mean? Moving shapes. And we were just doing vertical translations. So we were moving them up and moving them down. Okay, so here's our function. 2 to the x. Here is it translated. It's the same function, 2 to the x, but we've added 3. What will that do to its graph? Raise it up on the graph by 3. Here's t to the x, and it's starting out with 2 to the x. That's the basic function, but it's minus 3. What will that do to our graph? Go down 3. We're looking at ordered pairs. Okay? So when we did this in a table yesterday, maybe we'll go to that in a minute, but let's look at this in math. So goodbye to graph, mode clear, and now this is saying x is minus 2, what's y? Well, here's what we need to do. We've got 2 raised to the, and we're replacing the x, that little tiny x right there. Is that big enough for you to see? You have one in your own book. But this is x. They want us to replace it with a negative 2. So in my calculator I have 2. I'm going to raise it to a negative 2. Enter. 0.25. You know what? I'm going to be smart about this. I know that when x is minus 2, it's 0.25. I'm going to add 3 to that. That's what's going to be right here.
2.5.
Okay? So plus 3 is going to be 3.25. And right here, I'm going to go back to 0.25. And this time, what are we going to do with it? Minus 3. Negative 2.75. Okay? Now I'm going to go back down here to the next one. I start with a 2. Maybe I'll clear it so there's not so much stuff. I start with a 2. All of these, the base function is 2 to the x. They're giving me x's. X is minus 1. So 2, raise it to a negative 1. Enter. That's 0.5. Did I write the wrong thing right there? 0.5. What am I going to do as I move over to this column? Add 3. What am I going to do as I move over to this column?
It's going to be you're in minus 3.
Minus 3.
Negative 2.5.
There we go. Negative 2.5. Okay? You guys, fill in the rest of the y's, please. Fill in the rest of the y's, please. In this column, it's all 2 to the x. In this column, 2 to the x plus 3. In this column, 2 to the x minus 3. And they're giving you what they want you to use for x. I'm going to walk around. Zero is fine. So now that's going to be 1. That's 1. That's 1. this is going to be 2 raised to the first power. Okay, kind of on it there. What we're noticing is you can have a and then ones that are really kind of close, they're just they're called families. Are you getting it quiet? Are you catching up, kind of? Good. Actually, what we started here has nothing to do with the before. Only the real data catch up on is yesterday understand.
I'll pick it up for you.
Ladies on it. Okay.
Sitting down.
How you doing? Don't put in X, because what they're telling you is use this for X. So back up. But here's the got too many things. Clear. 2. There's another 1 right there. No, well, here is 1. Here's 1 plus 3. And here's 1 minus 3. Okay, what your buddy has is either ask him to borrow the calculator or ask him how he got his number. Okay, Memo. Here we go. 1. There we go. There. There's the function. The next X. So go 2. Enter. Now right here is that plus 3. Okay, let's do 1 minus 3. There you go. Next line. Yes. Well, one of these 2 is wrong. This one's wrong. Okay? So you got 2 that are exactly the same. Okay. Here we go, my friends. Let's see. Imogen, can you tell me what numbers go across this row?
1, 4.
Okay. Jerry, could you tell me the numbers that go across this row?
Yeah, 2, 5, and -1.
Anna, could you tell me the numbers that go across this row?
4, 7, 1.
Do you guys agree with them? All right. Number 12. Use the table to compare ordered pairs for the graphs. Excuse me. Use the table to compare ordered pairs for the graphs of S of X and T of X to the ordered pairs of H of X. What do you notice? What do you notice about the ordered pairs? First of all, what's one big thing to notice about the table as a whole? Bunch of numbers. Is there any pattern?
Yeah.
Jerry.
If the first one is odd, then the other 2 are even.
Okay. Interesting. If first number is odd, the other 2 are even. Okay. What do you notice about this? How about these 3? 1, 2, 1, 5, and 1, -1. Maybe looking at the whole table is hard. Here's a piece of it. What do you notice?
They all have the same first number.
They all have the same first number. And that first number is the x coordinate. They all have the same x. Andy, you look like you got something. No? I thought I saw.
Yeah. The 2 plus 3 is 5, and 2 minus 3 things.
Okay? So S of x is 3 bigger. And T of x is 3 smaller. Okay, so those numbers, it's fairly easy to see that pattern. 3 bigger, 3 smaller. This pattern right here, where they all have the same x, that looks simple, but that's important. If they all have the same x on the graph, that means they're moving up, they're moving down, but they're not moving side to side. Okay, whatever that graph is staying centered in the area where it's going up and down. Explain how you know that the graphs of S of x and T of x are vertical translations. What would we look for if we didn't know this was a section on vertical translations? Molly? Same coordinates, or are all the coordinates the same? Or is there one in particular that's the same? Same coordinates. For example, if I'm looking at these because you can see them, what's the same here? Same x coordinates. That tells you, that it's vertical. Okay, same x coordinates tells you that's vertical. Oh, that's the same thing we just said up there. Same x coordinates is a clue to this kind of translation. 14. The last piece here, I think. Oh no, they got more on the other side. If we have 2 to the x as x and y, we can write that as x and y plus 3. X is going to stay the same, but what's going to be the y right here? Y minus 3. Okay, so that's just another way of representing the same thing we're saying. We're working with the same x's, and then we have a slight change into y's each time. Flip the page. I don't like 15. I don't think that'll be helpful for us. All right, I think I like this one. 16. This is z of x. They want us to draw z of x plus 3 and z of x minus 4. What's that going to do to this shape? Like that, but do what? It's not going to make it straight. They want us to work with z of x each time. But what does this plus 3 and minus 4 do to the shape? Raises it and lowers it. So let's think about plus 3 first. Each step of the way we need to go up 3. I think I'm going to pick corners, like right here. This point, 1, 2, 3, up. I'll put another dot. That's going to be one piece of my new shape. This point, 1, 2, 3, put a dot. I'm not going to worry about that diagonal. I'm going to come down to this corner. 1, 2, 3, put a dot. This corner. 1, 2, 3. I'm just counting boxes. And I'm doing it at easy spots that's going to be easy for me to sketch. From this corner, up 3, 1, 2, 3. Everything I plussed 3. Now, I have a straight line. I have a straight line. I have a straight line. And then here's a diagonal. And here's a diagonal. This is z prime of x. You see that little tiny hash mark that they gave it? That's called z prime. Z prime of x. This is z of x. How are we going to draw b?
Go down 4.
From each of those dots that I drew before, I need to go down 4 from the original. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. All right, straight line, straight line, straight line. I'm copying this z of x. Okay, and it's easiest to count corners, down, down, down 4. And then it's next easy to make those straight lines. And now I'll go ahead and fill in as best as possible the diagonals. Now this one was z of x prime. That's the plus 3 version. This is z double prime of x. That's the down 4 version. Write the equation of each function after a vertical translation of 6 units down. Oh, can you see? There we go. All right, so new function. This is 5x. I'm going to do p prime of x. It starts with the basic 5x, but what's down 6? What do I have to do to this?
-6.
This is a different function, 3x squared, but also they want us to go down 6. Brody, what do I have to do? 3x squared
-6.
minus 6. Okay, same thing, different function. Okay, I start with 1/2 x cubed. Oscar, what do I have to do with that? According to their instructions, I'm
I got you.
good. I'm bringing it down 6. So this r of x is the basic. R prime of x, they told us to bring it down 6, and we do that with a -6. Questions? Oh, phew. That's good. That's it for today. Okay, books away, homework packet out.